Hello, good morning, good evening, good afternoon, whichever time zone you are in. I'm so happy to have you on today. We do have Bryan Muir with Muir Engineering. Is it Muir Engineering?
That's right. Yep.
Okay, perfect. Sorry about that. I have Bryan on the line with us, and he is going to give a great presentation. I'm so excited to have him. While we're waiting for everyone to join, because we did have quite a few people registered, I do want to find out where you are from. So if you could, go ahead and type in the question answer panel where you're joining us from so that we can get to know you a little bit. Okay, so I see we have, I don't know if I can pronounce this name, Ayode from Nigeria. Welcome, nice to have you. Excellent. So yeah, so while we're just giving everyone a minute to get logged in, get their sound working. So if you could go ahead and type in the Q&A panel where you're coming in from. I always love seeing a global audience. It's nice to know we're all one small little world. Oh, great. Mohammed is from Dubai. Nice to have you, Mohammed. We'll give everyone just another minute or so. I still see the numbers climbing slightly. How are we doing on time? Oh, we're just 3 minutes after the hour. Okay. Well, I think the numbers have leveled off a bit, so I'm going to go ahead and jump in. Just really quickly, I do need to present this safe harbor statement. Basically, it just lets you know if we make any forward statements, saying this or that is coming up in the software, it's just to let you know this is not a promise that it'll be in the final version. I don't expect us to do anything like that today. Bryan has been using the software for a while and has a really good workflow set up for his company. So we probably won't be worrying about that too much. All right, and to let you know as well, your lines are muted to reduce background noise. And the reason for that is we do a recording of this. So you'll actually receive a recording after this is all said and done so that you can go back and watch this. You can share it with your coworkers or others that you think it would be useful for them to see the presentation. And if you do have questions, I do highly encourage them. So if you could put your questions in the question panel, that gives us record of those questions so that if we don't have time to get through all of them, we will try our best to get to them afterwards. And if you would like to unmute your line at some point to ask a question live, I do encourage that as well. So I will just raise your hand in the attendee panel and I'll be able to unmute your line and let you ask that question. So just as a reminder, our monthly meetups are meant as a way to let you connect with experts like Bryan in the field, as well as get your questions answered. We're here to help you. I'm Michelle Rasmussen. I work in the customer success organization, and your success really does matter to us. So that's why we have these meetups, to give you that opportunity to ask your questions. If I don't have the answer, or if our expert on the line doesn't have the answer, I will do my best to find that answer for you and get back with you afterwards. All right, so this is where we are in our lineup. Our building engineering community virtual meetup, we've joined together with a few different engineer types in the building engineering community. So we've got electrical, mechanical, and structural experts that will be meeting with you. And they will rotate on a regular basis. You can see we're on our third meetup, and Bryan is here for his second time, so I appreciate you joining us, Bryan. It's very nice to have you share your expertise. I know it's sometimes difficult because you've got competition joining these, but it's amazing that you're willing to share, so thank you very much. Next month, what's that?
Happy to help, yeah.
Oh.
Good to be here.
Good, good. I know you're very passionate about it, so that helps a lot. Whoops, that did not go right. There we go. So next month, our focus is on structural engineering. We'll actually be learning what is new in structural steel and in Revit. So you don't want to miss out on that conversation. All right, so with that, I am going to let Bryan introduce himself. Like I said, he is the president of Muir Engineering, and he has a lot of expertise. He's actually moved his company over to Revit for the electrical design. You said 100% now, right?
Well, we do some work in AutoCAD still on certain projects, but it's largely Revit workflow here. Yeah.
Wonderful, wonderful. Well, Bryan, what else would you have the community know about you?
Oh, well, I guess just that, yeah, Revit is something we're pretty interested in from a point of view of just taking complete control of all aspects of our design and understanding really what's going on deep into the design process. Um, so I'd just like to, also I'm really interested in trying to form a community of like-minded users who can influence Revit product direction for electrical engineering. So if any of the participants are interested in that, please reach back to us and let's try and form a community here.
I love that. Thank you. Excellent. All right. Well, Bryan, I'm going to turn over presenter rights to you so that you can share your screen. And give me 1 second to do that. Okay, Bryan, you should be able to share your screen now. And with that, I'm going to let Bryan just take it over from here. He does have a lot of information to share. And at the end of his presentation, we'll open it up to question and answers. If I see questions coming in that are relevant to something he's talking about right at that moment, I may interrupt, but most of the time I try not to interrupt too much. So Bryan, the floor is yours.
Sounds good. Can you see my screen yet?
Yes, I am seeing it. The PowerPoint is small, but yeah, if you want to make that bigger.
Is
Perfect.
that better?
That is much better. Perfect.
Okay. Right. So we're a consulting electrical engineering firm located in on Vancouver Island in Canada. So this is just a quick shot of that. If you joined me for the presentation last time, you would have seen a similar slide. And we do, let's try and advance the slide here. Okay. So we work on all sorts of projects. We're in a small market, so we get to do a lot of interesting and diverse stuff. So this is a photo of a First Nations band office we worked on with a local architect. You can see the lighting design off on the right there. And I'd just like to mention quickly, last time I brought this up, that Autodesk uses a system, a democratic system for voting up ideas called the Revit Ideas Forum. And if we want to get a new feature into the product, the way to do that is to post online here and then vote it up as a community. Last time I mentioned this idea of flexible conduits, which I really think would be a great adder. At the time, it had 133 votes, and after the session, we gained a whopping 4 votes. So I found that a bit disappointing. So I hope this time you guys can go onto the Ideas Forum and check it out and vote for electrical related ideas so we can get those into future products. So this is the flexible conduit idea, and see we went from 133 to 137, which is probably enough, I'm hoping, to make it into a future release. But there are some other great ideas that don't have enough votes and they will be ignored. Okay, so moving on to today's topic, I'd like to talk to you about emergency lighting systems and how we handle these in Revit. So starting with, why do we need emergency lighting? What are the types of emergency lighting? I'll break into a topic, some general ideas about how we model electrical equipment in Revit, and then come back to how we apply those techniques to the emergency lighting systems. And I'll go into Revit and show you for each type of solution how we handle it. And I'll talk a little bit about the engineering issues. So not Revit issues, but the actual practical engineering issues that we have to think about as designers when we deal with emergency lighting systems. And then from there into questions. So moving forward, emergency lighting systems, what are they and why do we need them? Well, I think if all of you should be familiar, or should have seen these systems in buildings. So these are the little remote lighting heads on the walls. And these are designed to help everyone get out of the building if the primary power is lost. And that can be really important because that power outage could be associated with some major disaster, like an earthquake. So an earthquake comes along, the building's partly collapsed, power's out. We need to get those people out safely. Not only that, your local codes all around the world will require you designing these systems. So it's not an optional thing. So about the code requirements, some examples: NFPA 101 Chapter 7, the IBC 1006, here in Canada, National Building Code 3273. All these standards require a minimum level of lighting. NFPA, for example, requires 1-foot candle on floors, 10-foot candles for stairs. Canada's similar. I'm not sure about IBC. NFPA requires the lighting system has to be enabled within 10 seconds of the power outage. So those codes also go in to talk about the minimum runtime for emergency lighting. Here in Canada, 30 minutes for most types of buildings. I'm actually not sure what NBC calls for in the US. And one important consideration as you design forward is this clause, both out of Canadian Electrical Code and NFPA 70, is that the supply circuit to the emergency lighting unit shall be connected to the same circuit supply as the normal lighting in the area. So what this means is that if the circuit supplying normal lighting in an area goes down, the emergency lighting in that area is supposed to activate. So you can't simply put your emergency lighting systems on an independent circuit and expect to meet the code. And here in British Columbia, we're seeing the inspectors actually pay attention to this. And the way they test the systems and the way we also test is we switch off the breakers serving the lighting to the area, and we expect to see the emergency lighting come on. So as you design, this particular clause will be important, and I'll talk about this a little more as we get into some of the systems. Okay, so now into the types of emergency lighting systems. You can meet these code requirements in a few different ways. One is with self-contained battery units. Second is battery units that supply remote heads operating at a DC voltage, typically 12 volts for us, but it can also be 6 volts or 24. Another one's emergency lighting inverter. Another is a generator. So I'll get into all these a little bit. Slide seems to be stuck here. Hang on. Okay. So this little guy is a self-contained AC backup unit. So it simply connects to, for us, 120 volts AC. For those of you in Europe, it might be another voltage. It's simple to design with. You simply connect it to an adjacent lighting circuit. And in Revit, we handle it just like any other AC supplied fixture. So it's pretty easy to work with. Electricians like this as well because it's easy for them in the field to deal with this. Pretty simple. Number two is getting a little more complicated. Here we have a battery unit, which may or may not have heads on it. And it's driving DC power up to a number of these remote units. These remote units can be fancy ones that retract into the ceiling, or they can be simple like the ones we've shown here. The design's a little more complicated, so as I get into the details, I'll talk about some design considerations you need to think about when dealing with these systems. And it's a little more complicated in Revit as well. Next solution is an emergency lighting inverter, more appropriate usually for a larger building. This is an inverter unit, and this is a big one I show here, usually installed in the electrical room. So AC power comes in, comes through this unit and goes out to the lighting systems. And if power goes out, this will take over. It's a giant UPS and it will supply AC power when the building is out of utility. So the normal lighting circuits and lights serve as your emergency lights. And the fourth solution is a generator. You can design your building with a permanent standby generator and power your regular lights this way and meet the code requirements. But be careful here. You can't simply throw in a generator as a solution. You need to pay attention in North America, at least, to NFPA 110. That's a standard for emergency and standby power systems. There's a lot of detail there. So just if you want to go this route, it's beyond the scope of this presentation today, but just be aware the standard is pretty important. So there's no special attention this needs in Revit, and I won't come back to this today. So just a sec while I get a sip. Okay, I'd just like to break away for a second and talk about modeling electrical equipment in general and some of our design philosophies we have in-house and why those are important to us. Now, depending on your workflow, accurate modeling in Revit might not matter to you, and I'd encourage you actually to model only to the level that you need to in order to produce decent contract documents. There's no point in modeling just for the sake of modeling. So we like to model so that devices connect to each other inside Revit just like they would in the real world. So if an electrical contractor is going to connect device A to device B using conductors, then in Revit, we want to connect device A to device B using Revit's circuiting tools. So we care about accurate modeling at Muir Engineering for a couple of reasons. One is in your panel schedules, there is one of the items it can display is the source. So if you model accurately, that source information will be displayed properly. The second one is we use a tool called Design Master RT, and perhaps one day I'll give a seminar on that. Design Master RT can generate one-line diagrams out of Revit. And here's an example of one-line diagram in a more complicated project we generated using Revit topology. So we have a couple of transfer switches, a main distribution panel, and a bunch of branch feeders, all with metering. So that's a useful tool if you're interested in maintaining a one-line diagram synchronized with your Revit model. So for us, this accurate modeling is important. For you, it might not be as critical. Okay, so just moving on to how we model here. So the first thing you need to think about if you're modeling a new device is what family type you want to use. So you could use electrical fixture, electrical equipment, perhaps a light fixture, obviously for lighting, or in some cases, a mechanical family is the most appropriate. So I'd like to give you some pointers on how we pick what family to use, family type to use. So if power goes into the black box, so here's your family, just this box here. If power comes in and doesn't go anywhere, then that suggests you should model this as an electrical fixture, a light fixture, or a mechanical family. None of these families are support external connections in Revit. So examples would be a street light, receptacle, any appliances, mechanical equipment like hot water tanks, baseboard heaters, even a fire alarm panel that wants a 120 volt connection, but doesn't have any AC connections out. That's a good thing you can model as an electrical fixture. So next case is power goes in and comes out at the same voltage. So in this case, Revit gives us a couple of types to work with. Electrical equipment, subtype, panel, or switchboard is what we need to use. And it turns out this is useful for more than just panels and switchboards. So we use it here for equipment disconnect switch. Now Revit contains a part type, electrical equipment switch, but that part type is frankly useless because it doesn't support a downstream connection. So what we do is model instead as a panel with just a number of output single pole breakers equal to the number of poles. So for a three-phase device, we only allow it 3 poles of output breakers. In other words, 1 3-pole circuit. Then we can connect that disconnect switch to a source, and we can connect a mechanical device downstream to the switch and have it appear in our one-line diagram. Number 2, you saw in the one-line diagram we showed automatic transfer switch. So we model these as well as panels, only Revit gives you the ability to set up multiple sources on a panel. So that's how we handle a transfer switch. And with a transfer switch, there's no change in voltage, so the panel class works well. So the next general class is power comes in and goes out, but it's at a new voltage. So this is fairly obviously a transformer type. So electrical equipment transformer, and of course, all your transformers you can model in this family type. But we use it for something else, and I'll just put that as a teaser, and you'll see that coming a little later in the presentation. Okay, so now I'd like to get into showing you in Revit how we model these different lighting systems. So perhaps at this point, could I get a check from Michelle as audio's good, everything's good?
Yeah, everything seems good, and no questions have come in so far, so you're doing great.
Okay, all right. I see we have 20 persons attending, so okay. So moving along to Revit, let's see here. Let me get a little bit organized here. Okay. So what I have here is a simple little apartment building with some pot lights in the corridor. And I like to talk about doing emergency lighting, standby lighting for the corridor so that the occupants can get to these staircases here and here and get out of the building. So we would also include exit signs placed so to direct the occupants to those the exits, and those are modeled as just light fixtures. But we're here to talk about the backup lighting. So let's get into the first type we talked about, which is the AC system. So we can do system, just make sure I'm selected on that view, a light fixture. And if I bring my property palette over, here I've got a family backup light AC wall mounted. And it will host on a vertical face. So let's put one there, another there, and say, I don't know, one here, say. I'm not sure what, these things are some artifact out of our model that seems to be coming in from the architect's model. So just disregard those little stub outs there. So, okay, we place these 3 AC units, and you see these are showing up colored. We have a filter in our workflow that marks anything that's not on a circuit, just so we can trap it and know that we've missed something. So the easiest way to throw all this stuff on a circuit is just marquee select everything. We can do a filter and make sure we just have light fixtures. Okay. For some reason, I'm not getting my power. Okay, I see these are already connected to a panel. All right, that's why. Okay, so the easiest way would be marquee select them all and connect them to the panel, but these guys are already circuited, so but not connected to a panel. So I will connect them to my panel H, and you can see the color changes indicating they are now circuited. And let me throw on a tag. Okay. Okay, so here I've got a tag which shows the designation and the circuit number. So we've designated these pot lights as POT on circuit H10. So now it's just a matter of putting our backup lighting system on a circuit as well. So we can do that by taking the circuit, editing it, adding some devices in, and boom, those 3 devices go in. And we can take the same tag and put it on these backup lights, just something like this. So that's pretty much it. We're done with this floor, AC lighting. Drop them on as light fixtures, connect them to the circuit, you're good to go. So let's delete those and talk about the second type of lighting. Oops, sorry. Let me Let me get back to the slide. Okay. Okay, so let's demonstrate the DC system. So for this one, let's start with a battery. So that is our electrical equipment type. We've got this type called a battery, and we can do a search for battery. I don't see. Okay, we've got these, it's batteries. Okay, so we've got this family with a few types. We've got different wattages, and this suffix indicates there's heads on the unit. So I'll just pick this guy, which is a 72 watt unit with no heads. And I'll put it in this electrical closet right here. So you recall we talked about how to model different families. So an emergency lighting battery takes in AC at 120 volts and provides, this one provides 12 volts DC. So because the voltage changes, we model this as a transformer, okay? So just like any other transformer, we have a few steps to do in Revit to make it functional. So first one is picking the primary distribution system, that's here. It's a single phase device, so I'm going to put it on the 120/208 volt single phase system. So that's step one. Step two is giving it a name. So I'm going to call this B3. I'm on floor 3, so I'll call it battery 3. And I can tag it with B3. Okay. The next step is to give this a secondary distribution system. So here we have a 12 volt system. So that's worth mentioning quickly under manage. MEP settings, electrical settings. Under our voltage definitions, we need to have a 12 volt voltage defined. And we also need a 12 volt distribution system defined, which is 2-wire, just 12 volts line to ground. Otherwise, this modeling cannot work. So we have our battery now. It's connected, or we can connect it at this point to the lighting circuit. So let's do that. So now battery B3 is connected to the same lighting circuit as these pot lights. So that's important because we want the remote heads that this battery feeds to go on when the circuit driving these lights goes off, per that code clause I mentioned at the start. So the next piece of our modeling is to add those remote heads. So again, it's a light fixture. And here we have a new family backup light remote head, dual wall. We can place those in a similar setup, similar locations. We might want this one over here. Right? Now these guys don't have power, that's why they're colored. So let's select all of them. Power. And here we can pick a panel. And in this case, we're picking battery 3. Now it might be an idea to tag those so the electrical contractor knows where to connect them. So this is our standard light fixture tag, but this B3-1 doesn't make a lot of sense because B3 doesn't have a circuit 1, 2, or 3. B3 is only one output. So we have, sorry, I'll just mute my phone here. We have a special tag that we have for a remote head. Just looks like this. And we can just tag all those remote heads with the battery number. So this is more or less the design complete for this floor. But there's something else I'd like to show you now, which is our schedule. Okay. Okay. So here's the sheet that this floor plan lives on. So here's the batteries we just added. Actually, that's a lower level, but what I want to draw your attention to is this schedule. So this schedule shows that B3 we just added. It's an emergency lighting battery. It's on the third floor electrical closet. This is coming out of the part. It has a 72-watt capacity for a half-hour run. So that's a parameter in the part. Revit is telling us that our total connected load is 30 watts. Each of those remote heads we just connected has two 5-watt LED heads. So a total of 30 watts. Total amps connected is 3 amps. So from this, we can tell that the wattage is less than the half-hour runtime rating. So we know that this battery unit is adequate for its job. So the batteries this should last at least 1 hour runtime, so we meet our code. Also, we have the part number of the manufacturer and the part number of the battery. So good stuff to give your electrical contractor. So just talking about what we need to make this work in Revit, we had a battery modeled on a transformer. We have a remote head, which is a light fixture, but modeled to expect 12 volts. We have a few custom tags. We have a custom schedule. And we have a few settings in Revit, the DC distribution system I showed you. So there's a few design considerations you need to watch when working with DC remote heads. So voltage drop on long DC runs can be an issue. You need to watch for remote heads spread out to other areas of the building. Just make sure that when the power to the battery is lost, when the power to the lighting in those areas is lost, it will cut out the battery, which then in turn will turn those lights on. So you also want to pay attention to how much you're loaded on the battery, and that's where the schedule I just showed you can give you a quick indication of what's going on. So we tend to design using these remote heads quite often, maybe 70% of our projects we go this way. I personally like the look of these remote heads more than I do the self-contained battery units, but it's just preference. So we can also go on and model the results in eLoom tools. So some of you may use that tool. So that's a photometric modeling tool available for use with Revit. And here we can see that in this corridor, we reach the 10 lux requirement is satisfied. I'm not quite sure how far apart these heads are. One of my colleagues built this for me, but we normally space them about 40 feet apart. Okay. So emergency lighting inverter. I'll talk about this one a little bit in Revit. So for this one, let's hop over to our electrical room. Okay, so here's our electrical room. I've built this up already. So here we have a part, which is our emergency lighting inverter. This guy is modeled as a panel with maximum number of one-pole breakers is 1. I actually think that should be 3 if this is a 3-phase panel. But in any case, the idea is that this guy has only 1 circuit out of it. So this guy connects. If we see where it's connected to panel H, our house panel, which is here. So panel H, our house panel, connects to the emergency lighting inverter. And in this case, I have another panel, which is, we call it panel LT for lighting. This panel is connected to the ELI. So H drives the ELI drives this little panel LT. And this panel LT can be used to drive lighting all over your building. So what we like to do is, in an emergency lighting scenario, we often pick up every second light with the ELI. So why don't I take these guys? I'm going to disconnect a few of them. Not sure why that one's not showing up, but okay. Okay, there it is. And I'll take these three in the middle and I will power them up from that panel. Okay, I don't see LT here, so I have some issue with the LT configuration. Let me go there. Sorry. Okay, it's not on distribution system. All right. So back here. So this guy is now on panel LT1, which is powered through the emergency lighting inverter. And this light next to it is on the house panel. So these two pot lights will respond a bit differently in case of a power outage. This pot light will go out because it's on the house panel. This one will stay on because it's on this panel LT, which is served by way of the emergency lighting inverter. So panel H serves panel ELI, serves panel LT, which then in turn serves our backup lighting. So this one's fairly simple in Revit. We model the ELI emergency lighting family using an electrical equipment class panel. Now, when you're designing with an ELI, you need to pay attention to how loaded you are. You can't exceed the runtime ratings of the emergency lighting inverter. As I mentioned, often we like to drive a little panel board, which then drives our individual lighting circuits. We typically pick up every second light. And just as a side note, if you're dealing with automatic lighting controls required under ASHRAE 90.1, and you have these multiple lighting circuits in play, things can get a little tricky. So we have some solutions for that involving multiple power packs that switch simultaneously both circuits using a common set of sensors, but that's a little bit beyond the scope of what we're talking about today, but just something to keep in mind. So that is all I have to say so far, but I'm happy to take your questions at this point. So please let me know what else I can tell you about emergency lighting systems.
Excellent, thank you. So I don't see any questions that have come in. Oh, Mark just asked one. So Mark is asking, can you nest more than one transformer or battery families in a family that share a single 120 volt input but offer separate 24 volt output circuits?
I don't believe that once you nest a family into another family, I don't believe that Revit gives you the ability to connect directly to that nested element. So I think the answer is no, it's currently not supported by Revit. But if you'd like to write to me with your specific application, I might have some ideas for you.
Okay. Great. So if you do have questions, definitely put those in the question answer panel, or if you'd like me to open up your line, raise your hand in the attendee panel and I can open up or unmute your line basically. So I'm just looking. I don't see any other questions coming in. You were very thorough, Bryan.
Good. Okay. I see we have 18 out there. So I hope you enjoyed the presentation. Also, everyone stay safe. I know it's of course a very trying time worldwide. So stay safe and keep well.
Excellent. Excellent. And I'm just going to put your email in here for the one you said to reach out to you directly. So let me get that in there. Oh, Mark is asking the question, can you add energy code calculations to the lighting calcs?
Yes, if you can build schedules, it will show you your lighting loads, and Revit does give you some tools that you can go on to build lighting energy density calculations. We haven't gotten into that so much here, but it's something we're intending to look at some point.
Okay. And Bryan, we do have someone asking the question, are you okay with me sharing your email with the recording?
Yes.
Okay, so I have explicit permission to do that. I will send that out with the recording then. Okay.
Yeah, please, if anyone's interested in joining me in forming a community that we can use to work with Autodesk directly, I'd be really happy to have your involvement.
Yeah, definitely. I highly encourage that because, you know, the more voices that you pull together, the louder that voice becomes within Autodesk. So I think that's a great idea, Bryan.
Right. And my feeling, Michelle, you and I have spoken about this a couple of times, but my feeling is there may be some ideas that have been posted that are actually not that difficult to implement, may not take a lot of time, and actually offer more of a benefit than their voting status reflects. So this democratic system of presenting ideas and voting on them is really neat and unique. But the problem is we as electrical designers are a minority in this community, and like any other democracy, minorities have trouble getting adequate representation. So we need to be more vocal and essentially lobby Autodesk for the improvements we think are important.
Yeah, definitely. And the forum that Bryan was mentioning earlier, that's a great place to do that. I am going to be a lot more active in making sure your voice is heard from these webinars as well. So at the end of the session, you'll receive a survey, and definitely let me know what you would like to see, because, you know, one thing that I can do is I can make sure that we cover topics that you will be interested in, to make sure that these sessions are beneficial for you. But on the flip side, I can actually pass your requests over to our product teams as well. So
that's great.
yeah.
And Michelle shared with me some of the feedback from the last session, and there were some questions that could lead to future presentations. We had some actually pretty good questions coming out of the last session, so I think Michelle and I will take a look at those and see what we can do for the next session. Also,
Yeah.
please, if anyone out there would like to present is it June, Michelle, or July? Our next electrical session?
I think the next available session would be in July. So I'll be reaching out to those that have already said they are interested in presenting, to start filling up from July till January. Sure. But I'll definitely keep all your emails if you are interested. Even if you don't get on the docket from July to January, I'll make sure that I roll back around and see if you're still interested after that January as well.
Right, and I look forward to meeting some of you at Autodesk in November. Hopefully we're a go in Las Vegas and not pandemically locked down. It's I'm planning on attending next time. I've never been, so I'm excited about that.
Excellent. I will be there if we have it. So.
Okay. I look forward to having a beer with you, Michelle.
Excellent.
Okay.
All right.
Thanks. Well, I've got a lot of clients needing my attention, so I will sign off there. Please write me or write Michelle if there's anything more we can help you with, or if you have some ideas, etc.
Yep, absolutely. All right, well, thank you again, Bryan, for a great presentation. Thank you all for joining, and I look forward to seeing you next month when we actually talk with the product team on what's new with Revit and Advanced Steel. So thanks, everyone. Have a great day.
Okay, bye, everyone.